Okay, and again, for the sake of the recording here, I'm going to go back and say what we were talking about. Why would this be a difficult problem to graph? And we've got now the discussion that it has both x and y in it, but then most functions do too. And you're saying that if we try to solve for y equals, that could be a little difficult. I'm trying to help me out with that. So Aaron, continue what you were saying. Pardon? Why would it be difficult to graph this on the Inspire or any other graphing device? Okay, take your Inspires. Let's look at that. Go to a new document. Pull up a entry line if you need to by hitting Tab. What's it wanting you to do? It's asking us to write it in what format? So it's wanting us to do f of x, f1 of x in this case. And we often say that, y equals f of x equals. So what would you type in order to graph this? So we have to be able to solve for y. In order to do that, yeah, every single graphing tool that you have is it's graphing a function. It's a function grapher. If you can't write it as y equals, then we have a problem. Now, we can, the nature of this equation, I slip up every now and then and say function, but the nature of this equation is such that we might be able to do what we call completing the square to come up with something, but it's not going to be nice. It's not going to be pretty. It's not going to be convenient at all to graph that. So we are stuck. I can't ask you to show me graphically what this represents. We could do a table of values, and we could do something like this and try to come up with some values in here that would work, but I can guarantee it's not going to be a function. Even without that, what does this represent? Okay. Okay, this gives the what? The slope. Hang on, so I'm going to write this out. The slope, that's the most important word. The slope of what? Okay, to a tangent line. The tangent, we say a line is tangent to a curve. Which curve? Whatever, yeah, the original. Whatever the original is. Okay, the curve of that, what's left? At a point. So if I could graph that, I would want to look for a place to draw. Maybe it has a place like this. I want to find a tangent, if I can draw that tangent there, a tangent, but in order to do that for this equation, what information do I need? In order to find the slope of that tangent line, I need what? Again, Stephanie?
X and y.
Yeah, I need both. I need both x and y of what? The original. Okay, I can't emphasize this enough. Now, this is called implicit differentiation. And one of the things that we talk about, and I will continue to bring to you today, is that we need to know what is the variable of differentiation. The variable of differentiation is found where? In our notation. Let's go down to this. This is a derivative. Which is my input variable? And it's found down here. Down here, okay? This is the variable, my input variable of differentiation. If, as we have up here, over here, y squared, if I don't have this letter matching that letter, is it a simple derivative? And the answer is no. It's really a composite function. Ryan, the outside function of this is? That's a 2. I'm sorry. Yeah, to square something. And the inside function is whatever, yeah, exactly. It's whatever y represents. So we have to use then our chain rule. And so this piece actually is over here. The derivative of the outside is 2 times whatever that quantity is. And then we must take the inside, the derivative of the inside function. That's what we're about in this section, implicit differentiation. Okay, let's do, man, I don't know if I want to get into this. It says find the slope, but find the slope of that function at x equals. Let's do the first part, and then I'll kind of think about whether we're going to do the other part. Okay. Move this out of the way here. Okay, part A. Find the slope of this using implicit differentiation. Now, the opposite of that is explicit. Explicit means you are able to write y equals. If I can write it as y equals, it's an explicit differentiation, or explicit function format. We're going to use implicit here. And so, first of all, I'm going to go through, and some of you, again, I haven't had a chance to look at your work, but if any of you did like my Math28 students did, some of them lost points because they didn't show me this line, this very important line that I'm showing you, and I have continued to show you in every problem that I work for you. It's called the line of intent. That is, it shows me the derivatives that I intend to take. Okay, so I got the derivative of the first term plus the derivative with respect to my input variable, x, of my second term equals the derivative with respect to x of my third term. The variable of differentiation matches the variable in my term, so this is just a simple problem. 2 times 4, 8, subtract 1 from the exponent. Plus. Move over to the second one. This is one where the variable of differentiation does not match the variable in the term. So I have to think of this as a composite function. First thing I do, remember I put those smiley faces over here? And I said, what if you had 9 smiley face squared? What would you do? Well, you would multiply 2 times 9 and subtract 1 from the exponent. But because this letter, this is a function in and of itself, we must then take the derivative with respect to x of the inside function. It becomes dy dx. What am I trying to find? Dy dx. I've got a dy dx. I just now have to solve it for that term. But first of all, what's the derivative of a constant? 0. Okay. Some people in the other classes lost a point because they didn't put equals between where they were supposed to, or in this case, a little arrow indicating that you understand that it's not a run-on sentence. We're going to start now with, if I had more room, I'd put down below. So I've got now 8x plus 18y dy dx is equal to 0. I want to solve for dy dx. What must I do? Yeah, I'd subtract 8x from both sides. Okay, I need more room yet. Let's see if I can get all this stuff down here. Okay. So I now have 18y dy dx equals negative 8x. Now what can I do? Yeah, we're doing the same algebra moves that we did back in Algebra 1. We just have to subtract and multiply and divide accordingly. So I have dy dx equals negative 8x divided by 18y. Can I simplify that? Sure. So I'm going to simplify it. Let's see, negative 4x divided by 9y. Okay. Now I didn't show my Math 50 classes this, so I'll show this to you. Go to your Inspires, add a calculation page. Some of you being any of my students I have in classes, have been asking how to check your work with implicit differentiation. If you try it with the derivative template, you know it doesn't work. So here's what we have to do. Everyone on that, go to Menu, go down to Calculus, and then you can use the up arrow key to get to the bottom of that list. And if you get to the bottom of that list, let's see if I can help this to work better. There we go. There we go. And I go down here. You see that letter E, implicit differentiation? We can do that here. Okay? It doesn't have a template now, so it's rather crude looking, but we can put this in. Let's see, we're working on, what is that, x squared? Now this is interesting. Minus, oops, I'm on the wrong problem. Plus on this one, isn't it? Plus 9y squared.
Yeah, isn't it 4x squared?
Yeah, I'm on the wrong problem. I'll go back and fix that in just a minute. I'm trying to find the y, wx. There we go. Okay. Y squared, and I'll go back here and put a 4 here. Okay. Equals 36. Yeah. I got to get down on that. Okay. There we go. Equals 36. Now, before I press enter, I'm going to have to put a comma. And I have two variables, an x and then comma y. This is what we have to do to use implicit differentiation. Comma x, comma y. Go into Menu, go to Calculus, go all the way down to the bottom. Pick up the command for implicit differentiation. Type it in. Press enter. Do we have the same answer? Okay, so we can check our answers this way. Now, this is then our derivative. We found the answer we want, but it says add x equaling the square root of 5. So I want dy dx at, I just put that straight line down there, at the square root of 5, and I would have negative 4 the square root of 5 divided by 9y. Now what I'd like to do is have nothing but just a numerical value. So let's go back up and look at this problem from the very beginning. If I know that x is the square root of 5, would I then be able to find y? Yes. So I have 4 times the square root of 5 quantity squared. I have 9y squared equals, let's see, the square root of 5 squared is 5. 5 times 4 is 20. Subtract 20 from both sides is 16. So y squared is 16 ninths, which means y is plus or minus the square root of 16 ninths, 4/3. So I now can say that this would be negative 4 square root 5, 9 times 4/3, or negative 4 square root 5 divided by 9 minus 4/3. And of course I can go through and do some canceling here. And I'd have 12, and my 4's and the 12's can cancel. So let's see if we can do this. This would be 12. This would be negative the square root of 5 divided by 3. How am I doing? And negative 4 the square root of 5 divided by negative 12, right? Down here. So that should turn out to be a positive